Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the Specimen Paper 2 for the year 2023. So let's get started. Question 1 says a length of string is measured between 2 points on a ruler. When the length of string is wound closely around a pen, it goes round 6 times. What is the distance once round the pen, the circumference of the pen? So the first reading here is at 2.4 and the final reading at this point is 15.6. So we subtract 15.6 minus 2.4 and then we divide by the number of turns the string was wound around the pen. So we divide that by 6, we get an exact value of 2.2 centimeters. So the answer is A. Question 2 says, when does an object falling vertically through the air reaches terminal velocity? So this happens when the air resistance or the drag force is balanced by the weight or equal to the weight. So when the acceleration of the object becomes negative, no, acceleration is 0, since terminal velocity means constant velocity. Acceleration is g, no. When the air resistance equals the weight of the object, yes, so the answer is C. Question 3 says an athlete runs 100-meter race in a straight line. The table shows how the speed changes with time for the first 5 seconds of the race. So we have speed from 0 to 6.8 and time from 0 to 5.8. What is the average acceleration of the athlete between times 2 seconds and 3 seconds? So this is 1 second and acceleration is calculated as v minus u over t, or change in velocity divided by time. So the final velocity at 3 seconds was 5.7 and the initial velocity at 2 seconds was 4.1. Then we divide by the time, which is 1 second. That gives a value of 1.6 meters per second squared. So the answer is A. Question 4 says the gravitational field strength on the moon is 1.6 newtons per kilogram. An astronaut has a mass of 75 kilograms. What is the weight of the astronaut? So the weight is equal to mg, the mass multiplied by the gravity field strength. So we multiply 75 by 1.6 and that gives an answer of 120 newtons. So the answer is C. Question 5 says two objects P and Q are placed in a beaker containing a liquid. Object P floats in the liquid and object Q sinks. So the density of P is less than the density of the liquid and the density of the liquid is less than the density of Q. So P must have the greatest density and Q must have the least density. So checking the choices here, A we have 1.2, Q 0.6, that's less, correct. But the density of the liquid is greater than Q, so it's not correct. B we have P having the intermediate density, so it's not correct. For C we have 11.3, 8.9, that is less, correct. But again, it is less than the density of the liquid, so it's not correct. So the final answer would be D, since the density of the liquid is between the density of the object P and object Q. So going from lowest to highest, we go like this. That's why this is the correct answer. Question 6 says a ball of mass 0.12 kilograms is hit by a tennis player. The velocity of the ball changes from 0 to 5 meters per second in 0.60 seconds. What is the average resultant force acting on the ball? So we can calculate force is equal to change in momentum over time, or m multiplied by the change in velocity v minus u over time. So we have the mass is 0.12 multiplied by the final velocity 5 minus 0, and then we divide by the time 0.60. That gives an exact value of 1.0 Newton. So the answer is A. Question 7 says a balloon and a mass are attached to a rod that is pivoted at a fixed point P. The balloon is filled with helium, which is a gas that is less dense than air, so it pulls the rod upwards. The balloon filled with helium applies an upward force on the rod. The rod is horizontal and in equilibrium. Which action causes the rod to rotate clockwise? So we have different positions for the balloon and the mass, but we don't know the forces. So I'm gonna choose a force for the mass, which can be divided by 2 or 3. Let's say it's 6 newtons. And in equilibrium, we have the clockwise moments equal to the anti-clockwise moments. So if 6 multiplied by 20 is equal to the force of the balloon multiplied by 30, from the pivot, we can get the force of the balloon, which is 4 newtons, by dividing 6 times 20 by 30. Then I'm gonna use these forces to apply the distances in the answers. So for choice A, moving the balloon to 40 centimeter mark, that is the clockwise moment. We have the force 4 multiplied by 40, that gives 160. And for the anti-clockwise moment, we have the load of the mass, which is 6 Newton, multiplied by the distance 30, that gives 180. So the clockwise moment is less than the anti-clockwise moment, so it's not A. Moving the balloon to the 20 centimeter mark, so now we multiply 4 by 20, that gives an answer of 80. And for the anti-clockwise moment, the load of 6 newtons multiplied by the distance 10, that gives an answer of 60. So now the clockwise moment is greater than the anti-clockwise moment, so the answer is B. Question 8 says a hole is made in a square tile of uniform thickness. The diagram shows the tile hanging loosely on a nail. Where is the center of gravity of the tile? So for a uniform object, the center of gravity should be in the middle, but since there is a hole here and the object is hanging freely, that means there is no moment due to the weight. So the center of gravity must be directly below the pivot so that the weight is passing through the pivot and there is no moment. So the answer is D. Question 9 says an object of mass 0.16 kilograms is moving forward at a speed of 0.50 meters per second. A second object of mass 0.10 kilograms is at rest. So we have the first object of mass 0.16 kilograms and a velocity of 0.50 meters per second moving towards an object that is at rest and has a mass of 0.10 kilograms. And the first object strikes the second object. After the collision, the second object moves forward at a speed of 0.50. So after the collision, we have the 0.10 kilogram object moving with a speed 0.50 meters per second, and the original object, which was moving, having a mass of 0.16, has an unknown velocity. We want to know the speed of the first object after the collision. So using the equation of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. We have the initial momentum of the first object 0.16 multiplied by 0.50 plus the initial momentum of the object that was at rest is equal to 0. After the collision, we have 0.16 multiplied by v1, which is unknown, plus the momentum of the second object 0.10 multiplied by 0.5. So first we subtract by this bracket here 0.10 times 0.5, and then we divide by 0.16. That gives a value of 0.1875, which we can approximate to 0.19. So the answer is B. Question 10 says a ball is at rest at the top of a hill. The ball rolls down the hill. At the bottom of the hill, the ball hits a wall and stops. Which energy changes occur? So falling down, that means we are changing gravitational potential energy into other forms. So we start with gravitational potential energy. So C and D are rejected. And stopping at the end means that there will be no kinetic energy at the end. So A is rejected. So the answer is B, from gravitational potential energy to kinetic, then into internal energy. When the object collides with the ground, it loses its energy as heat energy or internal energy. Question 11 says a man climbs a ladder. Which quantities can be used to calculate the useful power of the man? The weight of the man and the time taken. So we have force and time only. No. The weight of the man and the vertical distance. This is useful to calculate the work, not the power. We need time for the power. Work done by the man and the time taken. Yes, since power is equal to work divided by time. So the answer is C. Question 12 says a student uses her thumb to push a drawing pin into a notice board. The pin goes into the board but does not penetrate her thumb. Which statement explains this? So the force exerted by the pin on her thumb is greater. So solid objects transfer the same force. So anything about the force changing is not correct. So the pressure of the pin on her thumb is greater? No. The pressure of the pin on the notice board is greater? Yes, since it penetrated the board but not her thumb. So the answer is D. Question 13 says a submarine is a boat that can travel below the surface of the sea. A submarine is 20 meters below the surface of the sea. The pressure due to the seawater at this depth is P. On another day, the submarine is 26 meters below the surface of fresh water, not seawater. the density of the seawater is 1.3 times the density of fresh water. So we can convert this into a mathematical formula. The density of seawater is equal to 1.3 times the density of fresh water. What is the pressure due to the fresh water at a depth of 26 meters? So going from seawater to fresh water, the density is multiplied by 1 over 1.3. So we divided by 1.3 in the above equation. And the depth goes from 20 to 26. That means that the depth is multiplied by 26, then divided by 20 to remove the 20. So if we have 20, we can multiply it by 26 to get 26 and then divide by 20 so that 20 is removed. So we have these factors here for the density and the depth, and the pressure is calculated as rho GH. Rho is multiplied by 1 over 1.3, so the pressure is also multiplied by 1 over 1.3, and the depth is multiplied by 26 over 20, so the pressure is also multiplied by 26 over 20. So combining these fractions, we get 1. So it is the same pressure. So if the original pressure was P, the final pressure will also be P. So the answer is B. Question 14 says, when particles of a gas collide with the wall of a container, the wall experiences a pressure. What is the cause of this pressure? So is it the change in energy of the particles, the change in momentum of the particles? Yes, the change in momentum exerts a force which causes a pressure, so the answer is B. Question 15 says, a substance can exist in 3 different states, solid, liquid, or gas. Each of the 2 statements below describes a change of state. Change 1 says particles move much closer together but continue to travel throughout the substance. So if molecules are able to move, that's gas or liquid, but much closer means we are converting from gas to liquid, so this is condensation. And change 2 says particles stop traveling throughout the substance and just vibrate about fixed positions, so that's a transition from liquid to solid, so this is solidification, so the answer is B. Question 16 says copper is a type of metal. A block of copper has a mass of 2.0 kilograms. The block of copper absorbs 12,000 joules of thermal energy. The specific heat capacity of copper is 385 joules per kilogram degrees Celsius. What is the temperature rise of the copper? So we have the equation energy is equal to mc delta theta. So we need to calculate delta theta, the change in temperature. We divide the energy by the mass and the specific heat capacity. So we have 12,000 divided by the mass 2.0 multiplied by 385, the specific heat capacity. That gives an answer of 15.5844 and so on, which we can approximate to 15.6. So the answer is A. Question 17 says the diagram shows the gap between a hot surface and a cold surface. The gap can contain air, iron, a vacuum, or water. Which material in the gap allows the quickest transfer of thermal energy by conduction? So we need the best conductor, which is a metal. So iron is the answer. So we choose B. Question 18 says which row about boiling and about evaporation is correct? So boiling takes place only at the surface, no and no. So it takes place throughout the liquid. Evaporation takes place only at the surface, yes, not through the liquid. So the common answer is C. Question 19 says light travels at speed 2.0 times 10 to the power of 8 meters per second in a glass block. In the glass, the wavelength of light is 4.0 times 10 to the power negative 7 meters. What is the frequency of the light? So we can use frequency is equal to speed divided by the wavelength. So 2.0 times 10 to the power of 8 divided by the wavelength 4.0 times 10 to the power of negative 7. That gives an exact value of 5.0 times 10 to the power of 14. So the answer is D. Question 20 says, in a shallow tank, a water wave moves through a barrier with a narrow gap. The diagram shows the waves on the left-hand side and the right-hand side of the barrier. Which term describes the effect shown? So the spreading of waves is called diffraction. So the answer is D. Question 21 says, which statement describes monochromatic light? Light that never diffracts? No. Light that has a single frequency? Yes. So the answer is B. Question 22 says an object is placed 8 centimeters from a thin converging lens of focal length 5 centimeters. Which statement about the image formed by the lens is correct? So whenever you place an object at a distance greater than the focal length, it forms a real image in a converging lens. So it is real, not virtual. So C and D are rejected, and the real image is always inverted by a converging lens. So the answer is A. Question 23 says a ray of light travels through transparent plastic to air. The ray of light enters the air traveling parallel to the surface of the plastic. So when the refracted ray moves at an angle of refraction 90 degrees parallel to the surface, we call the angle of incidence the critical angle. So the refractive index of the plastic is 1.25, and we need to get the angle theta, which is equal to the critical angle. So we use the equation that sine the critical angle is equal to 1 over the refractive index. So sine C is equal to 1 over 1.25, and we use the calculator to get the inverse sine. We press shift sine answer. After calculating 1 over 1.25, we get the answer, and we press shift sine then answer. We get an angle of 53.130, which is approximately 53 degrees. So the answer is D. Question 24 says, what is the speed of electromagnetic waves in a vacuum? So we know the speed of light in air and vacuum to be 3 times 10 to the power of 8 meters per second, but we have units centimeters per second and kilometers per second. So converting from meters to centimeters, we should multiply by 100. So the power of 10 should be 10 to the power of 10, and we don't have the choices 10 to the power of 10, so C and A are rejected. And converting from meter to kilometer, we should divide by 1000, and dividing this by 1000, that gives a power of 10 to be 5, so we choose the power 5, so the answer is B. Question 25 says a pulse of sound is produced at the bottom of a boat. The sound travels through the water and it's reflected from the seabed. The sound reaches the boat again after 1.3 seconds. The seabed is 1000 meters below the boat. So we traveled 1000 meters going down and then 1000 meters going back up. Using this information, what is the speed of sound in water? So speed is equal to twice the distance mentioned divided by the time. So 2 times 1000, and then we divide by the time 1.3. That gives an answer of 1538.46, which we can approximate to 1500. So the answer is C. Question 26 says a sheet of ice floats on water. A source of sound S is positioned at the edge of the ice sheet. 4 microphones are placed equal distances from S. Which microphone detects the sound from S the first? So we need the fastest speed of sound, which happens in solids, so through the ice, so it would be microphone B. Question 27 says the diagram shows a bar magnet and 4 plotting compasses. Which compass correctly shows the direction of the magnetic field due to the magnet? So we have the magnetic field appearing to be going out of this side because this is the north side. So the arrow should be pointing to the right, so it's not B, and going into the left side because this is the south side, so D is correct. And A is wrong because it should be pointing backwards. So going from north to south, the compass A should be pointing to the left, same as compass C, it should also point to the left. Question 28 says a plastic rod is rubbed with a cloth. The rod becomes positively charged. What happens to the plastic rod and what is the charge on the cloth? So on the cloth, since the rod became positive, the cloth should be negative. And what happens to the rod? It became positive, so it loses electrons. So the answer is C. Question 29 says the electromotive force of a mobile phone battery is 3.7 volts. What does this mean? Electromotive force means the energy required to move a unit charge, which is 1 coulomb of charge. So we have the choices. 3.7 joules is the maximum energy of the battery. No. 3.7 joules is the total energy of the battery that can provide. No. 3.7 joules of the energy is provided by the battery to drive a charge of 1 coulomb, yes, around the complete circuit. So the answer is C. Question 30 says a computer engineer wants the speed of a fan to increase when the temperature inside the computer increases. The engineer knows that a larger current causes the fan to turn more quickly. Which component should be placed at X to make this happen? So we need something that reacts to temperature, so it is a thermistor. So the answer is B. Question 31 says a water heater is connected to a 230 volt supply and there is a current of 26 amperes in the heater. It takes 20 minutes to heat the water to the required temperature. How much energy is supplied by the heater? So the energy is calculated as VIT, voltage multiplied by current and time. So we have the voltage 230 and current 26, but the time should be in seconds, so we multiply the 20 minutes by 60. That gives an answer of 7,176,000 joules. So this is 3 10 to the power of 3 and another 10 to the power of 3, so that's 10 to the power of 6. So this is approximately 7.2 times 10 to the power of 6, which we can find here. So the answer is D. Question 32 says an electric kettle has a metal casing. The cable for the kettle contains a wire that is connected to the earth pin of the plug. Which danger does this guard against? So we have choices. The cable to the kettle becoming too hot, that's not the danger. The casing of the kettle becomes live, yes, this is the danger. Since if the live wire touches the metal casing, any person touching the casing of the kettle would get electrocuted. So the answer is B. Question 33 says an electric current can produce a heating effect and a magnetic effect. Which row shows the effect that a relay uses and one application of a relay? So it uses the magnetic effect. The heating effect is used by a fuse. So we have the choices: allowing a small current to switch on a large current in another circuit. Yes, this is the answer. So we choose C. Question 34 says the diagram shows a bar magnet and a coil of wire. The bar magnet is moved at the same speed in each experiment. In which situation is the largest electromotive force induced? So moving the magnet towards a stationary coil and moving the magnet in the opposite direction with the same speed. So this gives an opposite direction, but it gives the same electromotive force or magnitude of voltage. So it shouldn't be A or B because they are the same. They produce the same amount of EMF. For C, we have the magnet and coil moving towards each other. And in D, we have the magnet moving to the left and the coil moving with the same speed in the same direction. So this is basically no relative motion, so it would be C, since the speed is multiplied by 2 because there are two objects moving towards each other, so they get closer to each other faster. Question 35 says increasing the transmission voltage in transmission cables reduces power losses. What is the explanation for this reduction? So when the voltage is stepped up, the current decreases. So the current decreases, yes. Current increases, no. Resistance of the cable does not change. So the answer is A, because this reduces the energy losses as heat in the wires, because current causes a heating effect and the current decreased, so the heating effect decreased. Question 36 says there is an electric current in a straight wire in the direction into the page. This produces a magnetic field around the wire. All the field lines are circles, but only one field line is shown. So we have which row describes a magnetic field. So we have anti-clockwise or clockwise. For this we need to use the right hand grip rule. If the current is going into the page, pointing the thumb into the page, the fingers will close clockwise. So the answer is clockwise, C or D. And the spacing of the field lines equally spaced over the whole field? No. More widely spaced further from the wire? Yes, that represents that the field gets weaker when you move away from the source of the field. So the answer is D. Question 37 says the diagram shows emissions from a source passing into the electric field between two charged plates. What is emitted by this source? So we have one that is not deflected, that's gamma radiation, and one that is attracted to the negative charge, so it should be a positively charged particle, which is the alpha particle. So we have alpha and gamma radiation. Neutrons, no. Alpha and beta, no. Alpha and gamma rays only, yes. So the answer is C. Question 38 says which row in the table describes the process of nuclear fusion and identifies the change of the total mass of particles involved? So for fusion, large nucleus splits, no, that's fission. So two small nuclei combine to form a larger nucleus, yes. And the mass always decreases, either in fusion or in fission. We have a decrease in mass. That is what releases the energy. So the loss in mass is converted into energy. Question 39 says the orbit of the moon around the Earth is modeled as a circular path of radius 3.8 times 10 to the power of 5 kilometers, and the orbital period is 29.5 days, which is 710 hours. What is the orbital speed of the moon? So we calculate orbital speed, distance divided by time, but the distance is the circumference of the circle, so 2 pi r divided by the periodic time of the orbit. So we multiply 2 pi by the radius, 3.8 times 10 to the power of 5, and all the answers require the units to be kilometers per hour, so we leave kilometers as it is, but we use the hours, not the days or seconds. So we have 710 hours. That gives an answer of 3,362.8 kilometers per hour, which we can approximate to 3.4 times 10 to the power of 3. So the answer is D. Question 40 says, which statement does not describe redshift? The choices are all light emitted from all distant galaxies is at the red end of the spectrum. No, not all light emitted is at the red end of the spectrum. B says the light arriving at the Earth from a receding star is always redshifted. Yes. C says during redshift, the wavelength of the observed light is longer than it is if the redshift had not occurred. Yes, redshift causes the wavelength to increase. So the sentence is correct. The light from stars in all distant galaxies is moved towards the red end of the spectrum. That is the definition of redshift. So all are correct except A, so we choose A. So this was the end of the specimen paper. I hope you enjoyed this video and found it useful, and I will see you in another video.